Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review everything you need to know for the upcoming test on algebra. So we're going to start with some definitions. These will be very important, not just for your test, but throughout your whole maths career. They will come up all the time. So the definitions are there if you want to copy them down. Let's apply this to this thing here. So what we have here is just a whole bunch of letters or pronumerals. That's what really is the hallmark of algebra. A lot of people think, oh yeah, it's just that area of maths that has the letters. So each of these is called a pronumeral. They are standing in for the value of a number. We don't know what X, Y, and Z are. They just represent unknown numbers. So pronumerals are also called variables because they vary. X, Y, and Z, they can take different values at different times. So this expression has four terms. 1, 2, 3, 4. Now you can recognize a new term because they're separated by plus or minus signs. So every time there's a plus or minus, we are starting a new term. So in this expression, there are four terms: 4x, y, negative 3z, and negative 5. So negative 5 is called the constant term because of these terms, it's the only one that doesn't have a pronumeral or a letter attached to it. So the variables or pronumerals in this are x, y, and z. Now we also need to be able to identify their coefficients. Coefficients means number in front of. So the coefficient of x just means the number in front of x, and in this case is 4. Now look at y. It doesn't have a number in front of it. So in algebra, whenever we see a pronumeral by itself, we assume it's got a 1 in front of it. The coefficient of y is actually 1 because y and 1y are the same. You see, in algebra, if you have no operation written, so like 1y, there's no plus minus between them, we always assume it's times. So 1y means 1 times y, just like 4x means 4 times x. But you see, it doesn't matter if you times something by 1. It doesn't change its value. Alright, this term here with a z in it, it doesn't have a coefficient of 3. Its coefficient is negative 3. So if asked for its coefficient, we have to write negative 3. So this here does not have an equal sign. It is just 4 terms kind of brought together. And so it is an expression. So we would call it an equation if it had an equal sign. And we're going to do a lot on equations next term. All right, let's now look at writing our own expressions. So we need to be able to turn worded information into things that just have mathematical symbols. So when we write our own expressions, we're essentially asking how would you find out something. So if I have B friends and divide 500 amongst them, how much does each person receive? So what I want to do is I want to write an expression or like a term that tells me how would I figure out how much each person receives. Well, you know, if I had 10 friends, each would receive 500 divide 10. If I had 20 friends, each person receives 500 divided by 20. If I had 100 friends, each person receives 500 divided by 100. And if I have B friends, then each person receives 500 divided by B. So B is standing in for an unknown number. We don't know what B is, but this is how you would figure out how much each person would receive. You just take 500 and divide by the number of friends. What about an expression for the number halfway between X and Y? So if you have two numbers, here unknown numbers are X and Y, how would you find the number halfway between? Well, all you would do is add them up and divide by 2. So this is just an expression that tells us how we would figure out the number halfway between two numbers. You just add them up and divide by 2. All right, number 3 I included because we had a lot of problems with this in class. Perimeter of a rectangle is 48, width is x, write an expression for the length. So for this one, I'll just draw a quick picture. So what we're told here, we have this rectangle and the width is x. The perimeter is 48, which means it's 48 all the way around. So that means that this one here, the length plus the width, must add up to half of 48, 24, because 24 plus another 24 gives you 48. So the width and the length need to add up to 24. I'm going to write an expression for the length. How would I figure out the length if I know the width? If I know that two numbers add to 24 and I know one of the numbers, you just subtract it from 24 to find the other. So for example, if the width was 7, the length is 24 minus 7. If the width is 10, the length is 24 minus 10. And if the width is x, the length is 24 minus x. So that just tells us how we would find the length if we knew the width. We just take the width and subtract from 24. All right, let's now look at substitution. So to substitute means to exchange. You've probably heard it in sport. When you make a substitution, you exchange one player for another. In algebra, we exchange the value of a pronumeral for a number. So kind of questions you need to be able to do are like this. If a equals 3, evaluate 10 minus 2a. Now, evaluate just means give a value to. It means give your answer as one number. So if a is 3, 10 minus a, all I do is take the expression and everywhere I see an a, I'm going to replace it with 3. But just be careful here. 2a doesn't mean first digit 2, second digit a. Remember, no operation means times. It's 2 times a. So this will just be 10 minus 2 times 3. Remember, you are allowed to use your calculator for this test, so you can put this straight in your calculator if you need. 10 minus 6 gives you 4. So what about this one here? X is negative 7, y is negative 2. We're going to evaluate this expression. I'm going to substitute x for negative 7, y for negative 2, and come up with a one number only answer. So whenever you are substituting negatives in your calculator, use brackets. So in your calculator, you'd put it like this. X squared minus y squared, so I'm substituting y for negative 2, that's why I use brackets, minus 20. You can put this straight on your calculator and it will give you the answer of 5, because it's 49 minus 4 minus 20, square root of 25 is 5. Alright, so this one here says if m is positive, that's what m greater than 0 means, and n is negative, is mn squared positive or negative? So remember, mn squared means m times n squared. No operation written in algebra means it's a times. So note that even if n is negative, n squared is always positive. So we write it like that. So m times n squared is a positive times a positive, and so it would be positive. Another way you can do this, substitute any positive number for m, any negative number for n, you will always get a positive number. All right, let's now look at a time when you can't substitute. So which value cannot be substituted for x in this expression here? So just remember, you can't divide by 0. Dividing by 0 will give you an error in your calculator. This is 1 divided by x plus 2. This fraction line means divided. So we would have a problem if we tried to substitute x for something that makes this equal 0. So we can't have x plus 2 equals 0, because then we'd get a division by 0 answer. And that would happen if x is negative 2. You cannot substitute x for negative 2 in this denominator, then you'd be dividing by 0. So the answer to this is x equals negative 2. You can divide by any other number besides 0, but if you substitute x for negative 2, you've got 1 divided by 0, can't do it. All right, let's now look at operations with terms. So to understand operations with terms, we need to know about like terms. So like terms have the same sequence of pronumerals. So 7x and 8x, they are like terms, they both have an x. Something like 4BC and 5CB, they are like terms. Even though the B and the C's are written in a different order, they both have one B and one C. So both of these pairs are pairs of like terms. Something like, say, 7x and 7y, they are not like terms because they have a different pronumeral. Something like 2x squared and x, they are also not like terms. This has two x's, this has only one x. Because remember, x squared means x times x. So these are examples of terms that are not like terms. Now it turns out you can only add or subtract terms if they're like terms. We could add or subtract these, we could add or subtract these, we couldn't add or subtract these ones here. So you can still multiply and divide terms even if they're not like terms. And the rule here is when you're performing operations with terms, when you're adding, subtracting, multiplying, or dividing terms, you operate on the coefficients. So let's say we have 7k minus k. Well, these two are like terms. They both have 1k. So remember, if no coefficient, no number is written in front of a pronumeral, assume it's 1. So this is 7k minus 1k. Now, a lot of people think you cross out the k's. You don't do that. Think of it like this. If you had 7k's and you took away 1k, you would now have 6k's. The answer to that's 6k. So what about an expression like this? Well, when you have that, you need to identify the like terms. So 3a and not 5a, but negative 5a, they are like terms. So you can add or subtract. 3a minus 5a. Well, 3 minus 5 is negative 2. So I write that, then I just write the a. Now note also 2b and negative 5b. They are like terms, so you can subtract them. 2 minus 5 is negative 3. And then you just write the pronumeral. So this here is my final answer. I can't simplify this any further because these are not like terms and you can't subtract terms if they're not like terms. So what about this expression here? So there are 4 terms, but only 2 of them are like terms. So this term here, negative 7x and 5x, they are like terms because they both have one x in them. So we leave the x squared alone because it's got no friends, it has no like terms. But negative 7x plus 5x. Well, negative 7 plus 5 is negative 2, and then I just write the pronumeral. Now the negative 35, the constant term here, it has no friends, it has no like terms, so I leave it as it is. This is my final answer. It can't be simplified any further because none of these are like terms. So it turns out multiplying and dividing is much easier because it doesn't matter whether or not they're like terms. So 2m times 7, I just go 2 times 7 is 14 and then write the pronumeral. Negative 30b divided by 8. So when we're dividing, it's often easier to write it as a fraction. So negative 30b divided 8. So the fraction line means divide. Now, if you need to simplify a fraction, you can use your calculator. Negative 30 divided by 8, your calculator will tell you simplifies to negative 15 over 4. And I leave the b alone. I can't do any more with that because I can't simplify 15 over 4 and there's nothing to simplify with the b. So what about 8a divided by 2a? Well, again, for a division, I'm going to write it with a fraction line, 8a divided 2a. Now, if there is something that is on the top and the bottom, which is common, you can cross them out. A divided by a is just 1. So I'm left with 8 divided by 2, which is 4. So I couldn't cross out here because there wasn't a b on the bottom, but if you have the same pronumeral top and bottom, it can be crossed out. All right, let's now look at expanding. So expanding is when you start with brackets and you end up with something that doesn't have brackets. Now to expand, we use the distributive law. So the distributive law says a outside of b plus c equals a times b plus a times c. So it's called the distributive law because you take what's out of the brackets and you distribute it to everything inside the brackets. So for 4 outside of x plus 6, we distribute the 4 to the x, 4 times x, and then we go 4 times negative 6. For this next one, 3a is outside the brackets. So we go 3a times 2b, 3 times 2 is 6, and then write the pronumerals. And then we distribute the 3a to the 7c. 3 times 7 is 21, and then we write the 2 pronumerals. So for this one here, we distribute the 2x to the x. So 2x times x is actually 2x squared. 2x times negative 5, 2 times negative 5 is negative 10, and we still have the x. We can't simplify any of these because they are not like terms. Sometimes you'll need to expand and simplify. So if you get something like this, expand the first bracket, so 5 times x, 5 times negative 3. Then we're going to expand the second brackets, 4 times 2x, 4 times 1. Now this one can be simplified because these two are like terms. 5x plus 8x is 13x. Negative 15 plus 4, you can use your calculator if you need. They are like terms, and that just gives us negative 11. And then we're done. All right, something like this often trips people up. Remember, if nothing is written, the coefficient's 1. This is 12 minus 1 times 9 minus x. So note here, we still have to follow the correct order of operations. We don't do minus first, we do times first. If no operation is written in algebra, it's a times. So I'm going to leave the 12 alone for now. I go negative 1 times 9 is negative 9. I also need to distribute the negative 1 to the negative x. Negative 1 times negative x is positive x. Negative times a negative is positive. So I've got 12 minus 9 plus x. 12 minus 9 is just 3. This one and this one are like terms. The x doesn't have any like terms. I leave it alone. My final answer is 3 plus x. All right, let's now look at factorizing. So factorizing is the opposite of expanding. In expanding, we started with brackets and ended up with no brackets. For factorizing, we start with expressions like this and we introduce brackets. So when you're factorizing something, you're writing it as something times something. Like if you factorize 36, you could write it as 4 times 9, 12 times 3, or whatever. So you follow these two steps. You write the highest common factor out the front, and then inside the brackets, you divide each term by the highest common factor. So this expression here has two terms, 4x and positive 8. The highest common factor is 4, so that goes out the front. Now I'm saying, what do I times by 4 to get 4x? Well, that's just x. What do you times by 4 to get positive 8? Well, that's positive 2. There, we're done. If I were to expand this, I would get this. So factorizing and expanding undo each other just like multiplication and division. So for something like this, two terms, 18a, negative 45. The highest common factor of 18 and 45 is 9. What do I times by 9 to get 18a? You times by 2 to get to 18, and you need an a. What do you times by 9 to get negative 45? Well, that's just negative 5. Once again, if I expand this, I get what I started with. So this one here is a little trickier, but we can still do it. Highest common factor of 55 and 22 is 11. But there's also something else common. So common means shared, means they both have it. For example, if you and I both like maths, we have that in common, something we both share. This term and this term also share, they both have a b. So b goes out the front. Sometimes the highest common factor will just be a number. Sometimes it will be a number and a pronumeral. Okay, we've got the highest common factor out the front. What do I times by 11b to get 55ab? Well, you need to times by 5 to get the 55, and you also need an a to make it ab. What do you times by 11b to get negative 22bc? Well, you need to times by a negative 2 to get negative 22. Then you also need a c. So if you expand this, you would get that. So what about this one here? Well, here we have two terms, 12x and x squared, but there's no numbers in common, but however, each term has an x. X is in common, so that goes out the front. So what do you need to times by x to get 12x? Well, you're just timesing it by 12. What do you times by x to get x squared? Well, you times it by x. X times x is x squared. So this is my final answer. If you expand this, you get this. So just note, when you're factorizing, the terms in the brackets should share no common factors, or you've done something wrong. So that's all for the mainstream part of the test. I'm now going to go through the LEAP only section on algebraic fractions. So if you're not in LEAP, you can feel free to stop the video here, and best of luck studying for your test, but I know you will ace it. So algebraic fractions are just like normal fractions, but they have pronumerals in them. We need to be able to simplify them, so I'm going to do that first with a multiplication division question. So we have one algebraic fraction divided by another. So in order to simplify, first look if anything can be factorized. It turns out I can factorize these three expressions. So 4x plus 16, well, the highest common factor is 4, and then x minus 4 goes in the brackets. I can simplify x squared plus x. They have a common factor of x. So what do you times by x to get x squared? X. What do you times by x to get x? 1. All right, and then similarly, I can factorize 7x minus 28 as 7 outside of x minus 4. Now, x plus 1 can't be simplified, it can't be factorized, so I'm going to leave it as it is. Okay, when you're dividing fractions, what you do is you flip the second fraction and make it a times. So I'm leaving the first fraction exactly as it is. For the second fraction, I'm going to exchange the numerator and denominator, and then I'm going to change the divide to a times. Now, when you are timesing things, always see at this step if you can cancel, which will make our life easier. You can cancel anything on the top and anything on the bottom as long as it's being multiplied. So I can cancel the x minus 4s because it's being multiplied. I can cancel the x plus 1s because they're being multiplied. I can't just cancel like an x here and an x there because this x is being added to 1. This x is having 4 subtracted. So what's in blue is wrong. I can't do that. So after I've crossed out the common factors, I'm just left with 4 on top, and on the bottom, x times 7 is just 7x. That's my final answer. All right, let's now looking at simplifying an algebraic fraction involving addition or subtraction. So we're going to simplify this algebraic fraction. That basically means I'm going to give my answer as one fraction only. So whenever you're adding or subtracting, denominators need to be the same. So I'm going to multiply this denominator by 3 and this denominator by 2. That will make the denominator 6. 6 is the lowest common multiple of 2 and 3. But if you don't want to change the value of a fraction, you want to find an equivalent fraction, what you do to the bottom, you must do to the top. What you do to the bottom, you must do to the top. So the first fraction becomes 3x plus 3. I need to use the distributive law. I need to times 3 by x and then distribute it to the 1. And on the bottom, I just get 6. So for this fraction here, similarly, I need to times 2 by 7 and 2 by negative x. All right. Now, I can combine these into one fraction. When you're adding or subtracting, first you make denominators are equal, then you keep the same denominator and you only add or subtract the tops. So the top becomes 3x plus 3, but notice I'm subtracting the whole lot here. So I actually need brackets. I'm subtracting the whole of 14 minus 2x. So expanding those brackets on top, 3x plus 3 stays as it is. I get negative 14 plus 2x. I have to distribute this minus to the 14 and then distribute it to the negative 2x. 2 negatives makes a positive. I'm still left with 6 on the bottom. Alright, so to simplify even further, 3x and 2x are like terms. 3x plus 2x is 5x. 3 minus 14 is negative 11. And I have my 6 on the bottom. I cannot simplify this any further. I'm done. Alright, thank you so much for tuning into this video. Best of luck studying for your test, but you will ace it. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.